Good afternoon, all. This is Satvik Reddy Tangirala. Today, now I will discuss about the project presentation of data analysis for business analytics. Let me start the introduction. The title of the project is Analyzing Crime Patterns in India: Study of Crimes Recovery and Enforcement. Nowadays, more crimes is occurred in India due to several reasons, and different types of also crimes is occurring. I took the dataset from government dataset from the government site web portal. Mainly, the dataset offers a comprehensive overview of crime statistics for the year 2017, various states in India, and it contains SRC state name, like the state's name, SRC year, the reports here, cognizable crime reported by IPC, the number of reported cognizable crimes, registered murder cases, like the total number of murder cases, registered cases of state offence, the number of cases that have been registered as state offences, cases reported under the Prevention of Corporation Act and related section of IPC, the total number of cases reported under the Prevention of Corruption Act, and the value of property stolen, the amount of stolen property in terms of millions, value of recovered property, the amount of recovered property in millions, cases registered by protection force as registered, the total number cases as the railway protection force as the registered, case of the crime against foreigners, the total number of foreigners related crimes that have been reported. Like this, there is a many types of variables or columns in this data set I have. And the study problem of this project is how much is the national average for the number of murder and cybercrime cases, and what is the average number of cases by state. And we used some different type methodologies for this project to solve the question, like descriptive statistics, some regression or distribution description, some regression and correlation analysis, and analysis of mean. So by using different types of methodology, we would solve this problem. First, we go to the descriptive statistics. To comprehend the central tendency and dispersion of criminal cases, a summary of the data was provided, along with the mean, median, and standard deviation. In this, for the registered murder cases, the count is 108 from it took from 108 states, one from it took from 108 rows, and the mean value is 815.93 cases. Standard deviation is 980 cases, and the median is 396 cases. Like this, registered cybercrime cases in this project is count is 108 and mean 568, standard deviation 1124, median 141 cases. Let we will perform the distribution analysis. In this, to show the distribution of murder and crime cases among the states and identify skewness and outliers, histograms are and kernel distribution estimations were utilized. The first one is distribution of registered murder cases. The distribution has a pattern that is right skewed, suggesting that majority of the states have very low rates of murder cases, with a small number of states showing significantly higher rates. The number of states with lower murder cases is reflected in the distribution's peak, which is located at the lower end. Like the distribution of registered cybercrime cases. The distribution of cybercrime cases is also right skewed, with lower numbers in nearly every state. However, a long tail extends to the right, suggesting that a small number of states have extremely high number of cybercrime cases. The wider distribution and the existence of states with extremely high rates of cybercrime suggests that this distribution is likely spread out than that of murder cases. And then we will go to the analysis of mean. To determine the statistical significance of any variations between the average number of murder and cybercrime cases, a test was conducted. T-test is 1.726 and the p-value is 0.086. At the 5% significant level, the p-value is higher than the typical alpha level of 0.05. suggesting that there is no statistically significant difference between the average number of murder cases and cyber crime cases among the states. This shows that there may be little differences in the number of murder and cybercrime cases among the states included in the dataset. And the next, regression and correlation analysis. Correlation coefficients were used to evaluate the strength and direction of the relationship between murder and cybercrime cases. In this correlation analysis, the correlation is 0.67, says a moderate to positive, strong positive association between registered murders and registered cybercrime cases. This shows that states with greater rates of cybercrime also typically have higher rates of murder cases. A correlation coefficient of 0.67 is significant, indicating a positive link, but it is not perfect, indicating that other factors may influence the number of occurrences in each group. And there is some conclusions for this project is the statewide murder and cybercrime cases are linked by a moderate to strong positive correlation. And there is no significant variation in the average number of murder and cybercrime cases between states, showing that crime occurrence is similar. And I took the references from the Minister of Home Affairs from some Indian government like Indian. Thank you and everyone.